Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Vector Databases. The memory for smart ice. Imagine an AI chatbot. It knows a lot, right? But if you ask it about your specific company's documents, it's clueless. Why? Because its knowledge is general. To be truly smart and personal, AI needs to remember new, specific information. Traditional databases, like SQL or NoSQL, are great for storing structured data, names, prices, dates, but they don't understand meaning or similarity. They can tell you if a word is in a document, but not if two documents are about the same thing. This is where our memory for smart ice comes in. Don't be scared by the math. For us, a vector is just a list of numbers. Think of it like a coordinate on a graph, but with many, many dimensions instead of just x and y. For example, a simple vector could be backquote 2, 3, backquote. In AI, we use vectors to represent things, words, sentences, images, even entire documents, as these lists of numbers. The magic is that similar things will have similar vectors. Their numbers will be close to each other. And different things will have very different vectors. It's how AI converts complex ideas into something it can understand and compare mathematically. So, how do we get these magical vectors? That's where embeddings come in. An embedding is the process of converting complex data, like a paragraph of text, an image, or an audio clip, into a fixed-size list of numbers, a vector. Think of it like this. You give your AI model a sentence, and the model processes it and spits out a long list of numbers. Say backquote 0.1 minus 0.5, 0.9, backquote. This numerical list is the embedding of that sentence. Crucially, this embedding captures the meaning and context of the sentence. If two sentences mean similar things, their embeddings will be numerically close to each other. This is the AI's way of creating a unique, meaningful fingerprint for everything it processes. You might be thinking, can't I just store these vectors in a regular database? You could, but it wouldn't be efficient for what AI needs. Traditional databases are fantastic for exact matches. Find me all customers named John Smith, but AI often needs to ask, find me all documents similar in meaning to sustainable energy solutions. Regular databases can't do this efficiently. They don't understand similarity in the way AI does. Comparing millions of multidimensional vectors one by one for similarity would be incredibly slow and resource-intensive. We need a specialized tool for this specific task. This is where vector databases shine. They are specially designed to store, manage, and, most importantly, efficiently search through these high-dimensional vectors. Instead of searching for exact matches, they excel at similarity search or nearest neighbor search. Imagine a super efficient librarian who, when you describe a book's theme or mood, can instantly find all books that are similar, even if they don't share any exact keywords. Vector databases use clever algorithms to quickly find vectors that are close to a query vector in that multi-dimensional space. This allows AI to recall information based on its meaning, not just exact keywords. As a developer, vector databases open up a world of possibilities for building smarter applications. Less than all greater than less than li greater than less than b greater than intelligent search less than b greater than. Instead of keyword search, provide results based on the meaning of the user's query. Show me warm clothes for winter, find sweaters and jackets. Not just documents with warm and winter, less than li greater than less than li greater than less than b greater than recommendation systems less than b greater than. Users who liked this movie also liked these similar movies. Find products, music, or articles similar to what a user enjoys. Less than, li greater than less than li greater than less than b greater than I chatbots with context. RAG. Less than, b greater than. This is huge. You can give your AI chatbot specific knowledge. When a user asks a question, the AI converts the question into a vector. Searches your private vector database for similar content, e.g., your company's FAQs or internal documents. Retrieves relevant paragraphs, and then uses asterisk that specific information to answer the user's question. This is called retrieval augmented generation. RAG. Less than, li greater than less than li greater than less than b greater than anomaly detection less than b greater than. Find data points that are unusually far from the rest, indicating potential fraud or errors. Less than, li greater than less than, ul greater than. For developers, interacting with a vector database is similar to any other database. You'll typically use client libraries, SDKs, in your favorite programming language, Python, JavaScript, etc., or direct API calls. Less than ol greater than less than li greater than less than b greater than generate embeddings less than b greater than. First, you'll use an embedding model, often provided by services like OpenAI, Google, or Hugging Face, to convert your raw data, text, images, into vectors. Less than, li greater than less than li greater than less than b greater than ingest. Store. Embeddings less than, b greater than. You'll then send these vectors, along with any metadata, like the original text, document ID, to your vector database. Less than, li greater than less than li greater than less than b greater than query. Search. Embeddings less than, b greater than. When you need to find similar information, you'll take your user's query, e.g., their question, generate its embedding, and then send this query vector to the database. The database will return the most similar vectors it has stored, along with their associated metadata. You can then use this retrieved information in your application. Less than, li greater than less than, ol greater than. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.